In this section of MATLAB, we're going to take a look and see how we can use MATLAB to be able to evaluate multiple integrals or iterated sorts of intervals, ones that have double or triple intervals in it. And the first thing we're going to do is we're just going to take a look at some basic coding as to how we can evaluate not even applications or anything like that, but just a double interval and a triple interval. There's two methods that we can use. They both do the same thing. It just depends on how confident you are with your coding. So there's one way that you can just nest the int statements within inside of one another. And so you can use basically this nested form where you have a function and then you just say integrate the first function, and then outside of that, you're going to integrate it. So in computer programming, that's called a nested statement, where you just do the same or maybe two different statements that are built-in commands within one another. Another form is that you could just define a variable. So you could have a first iteration and then just have first represent right here. It's a little bit cleaner that way. If you make an error, it's a little bit easier to dissect where you might make an error with that. All right. In these videos, I'm just going to use the iterated form just to, for simplicity's sake when I'm going through and trying to code these. However, for those of you that are a little more advanced with your programming, if you want to use the nested function, that's perfectly fine with me. All right, so let's just go ahead and evaluate two basic iterated intervals. One's a double and one's a triple interval. And we're going to approximate the solution to 6 decimal places when it's appropriate. All right, so this guy, xy, e to the xy, dy dx, 0 to 2 for y, 0 to 1 for x. All right, so first we're going to define some sims variables. All right, so that's paramount to anything else. If that doesn't happen, then we're not going to get anywhere with this. All right, I'm going to define the function f to be equal to our x times y. All right, so don't forget, every time you do multiplication or perform multiplication in MATLAB, you need the explicit multiplication and then exp x times y. All right, so that's our function. We don't need the dy dx. I'm going to define the variable first to be the integration with respect to y. All right, so that's from 0 to 2. So I'm going to integrate. So first is going to be equal to integrate f with respect to y from 0 to 2. And then the next thing I want to do is I'm just going to call it second, or you could just call it the answer, whatever you want to call it. So in this case, it's the answer, and that's going to be equal to the integral of first with respect to x now. All right, so notice x is going to be our second integration from 0 to 1. All right, now I'm just going to go ahead and execute this. I'm not going to go ahead and approximate the 6 decimal places yet, but I just want to make sure that I get some answer out of this. All right, and I get this Euler gamma function. All right, and so what that means is that this is the precise value, although we don't necessarily know what this is off the top of our heads, and that's just because it's not really a nice value for us. All right, so to get the approximation, what I'm going to do is I'm going to use our old function fprintf, and we're going to fprintf that the approximation to 6 decimal places is, and remember we're going to use %.6f, all right, and that's going to call 6 decimal places of a floating point. I'm going to use /n. All right, so the forward slash is the one that's going to be for me above the enter key, and that's a return. And then I'm going to type comma answer. All right, and so what that means is that 0.6f is being referred to answer. Now I'm going to go ahead and execute this. Remember, semicolons to suppress anything that we don't want to echo down here in the command window. All right, and then here is our answer. Okay, so pretty cool that we were able to get that. Now let's take a look at a triple interval, right? And so this is our triple interval of xyz, e, xyz, dz, dy, dx. We have 0 ln 2, 0 ln 3, 0 ln 4. All right, so now I'm going to go ahead and define our sims variables x, y, and z this time. And our function f is going to be equal to x times y times z times exp of x times y times z. All right, so that's our function. Now I'm going to have 3 layers of integration, and certainly nesting this is possible, but it might be a little bit messy. All right, so I'm going to say first is going to be equal to the integral of f with respect to z. All right, so notice z is our first in our order, and the order or the integral is going to go from 0 to ln 2. And remember, in MATLAB, ln is log. Right? Now I'm just going to go ahead and execute this just to make sure it works. All right, so we go ahead, we run it. All right, and we get this really ugly value. Okay, notice it's in terms of x and y, which is expected because we haven't integrated yet. Second integral, or the second iteration, we're going to say int first. All right, so we're just taking the answer that we just got first with respect to y, because that's second in our order right here. And this time the bounds are 0 to log 3. And then finally, answer is going to be equal to int of second this time. This time we're going to have x 0 to log 4. Right? And so this should be the precise answer. Right? And I'm going to go ahead and run this just to get the precise answer, just to show you that it's probably not a really nice one. All right, so we have to wait a little bit. MATLAB's thinking. All right, and we get the Euler gamma function again. Not surprising. All right, so there you go. That's the exact value of this. Certainly, it wouldn't really be all that helpful to us. All right, so what we're going to do is we're just going to go ahead and we're going to copy this fprintf statement. And I'm going to say the approximation to, let's say, the first integral to 6 decimal places. And then I'm just going to say to our second integral to 6 decimal places. And let's just go ahead and run that. All right, and there it goes. All right, so pretty cool that MATLAB can go through and just evaluate these iterated integrals and at least give us both an exact, and notice the exact numbers weren't all that nice, but we can get an approximation when necessary. All right, and for most of us, the approximation is probably going to be more useful in real life, although we certainly want to be exact whenever possible. All right, so now that we know how to kind of compute these iterated integrals with MATLAB, let's go ahead and see if we can look at some of the applications that we've looked at throughout our class and use MATLAB to help us out with those.